guys, I think we're ready to get started. So this is Vision Programming with April Tags for FRC. I'm Andy Gosser. I'm a Java programmer with Team 7028 out of St. Michael Albertville, the Binary Battalion. Been working with them since their rookie year in 2018. And I like to do programming and control systems. And I'm going to be a CSA at the Granite City Regional in St. Cloud. So if you have trouble in St. Cloud, come find me. I can hopefully help you out. Can you guys hear me okay? Is it all right? So first question, what are April tags, right? April tags are these kind of barcode-y looking things, but by looking at them, a camera can tell the, yeah. Uh-oh, it's flickering here, maybe it'll come back. All right. By looking at it, a camera can tell how far away it is, what direction it's pointed, and its orientation. So the pictures that are up there, I took those at EMCC 2 years ago and then ran them through an April tag processor. And you can see there's little boxes that it can like identify that, oh, this one's turned this way and that one's turned that way. Interesting, there's kind of this one in the corner that doesn't show up. April tags do have to be flat and like mostly visible, including the white border, for them to be identified. So that's what April tags are. For FRC, they're going to this year use, there's different tag families. They're going to use this tag family. It's 36H11. There's 587 different tags. Last year they used a family that only had 30. Kind of hoping by allowing more, they're going to have more tags on the field, but we don't know yet. So last year, my box on the right there was a lot bigger. There was only 30 tags. Now there's a lot more options. This is the size they're going to be. They're going to be about 8 1/8 by 6 1/2. So why April tags instead of retroreflective tape? We've used retroreflective tape in FRC for years. Kind of that bottom right corner shows what a camera sees with retroreflective tape. We would have a bright green LED, usually a limelight, and turn the exposure way down so all we could see was the green reflection coming back. And then the top right there is an April tag. It's kind of the same position that we're seeing. There's tape on these poles, and here we're seeing just the tape reflected back. One big advantage is we don't have to have bright lights on our robots. The limelight, everybody kind of complains, it's shining in my eyes, and in the pit, nobody can see. But it also gives us that 3D positioning and orientation. We can tell how far it is from the camera and what direction it's pointed, so we can pinpoint where the tag is in relation to the camera. And then each tag is unique. So on the previous screen, we saw all those different tags, over 500 different tags. The camera can identify that's tag number 1, that's tag number 2. Where with that retroreflective tape on the bottom, I have no idea which node that is. Is that the one on the far left, the one on the far right? No way to know. And it also needs less calibration at the competition. If you can see with your camera, you can most likely see April tags. There's some optimizations you can do, but you can most likely see it. So there's less need to drag your robot out and make sure every single node can be seen and all the reflections and everything. And it's also less susceptible to field lighting and arena LED signage. We had a big problem in 2022 at Williams Arena. They have a big marquee that goes all the way around. They put green on that, and then our lights wouldn't, or our camera couldn't pick up the retroreflective tape. So last year for FRC, they used 8 different tags, and they were near the scoring locations in the human player double station. So the top there is a picture. You guys probably all have seen one of the events, at least at an off season. And then the bottom right shows where all those tags were. So you'll see there's 8 different tag IDs. So if you can see a tag, you can know which tag you're looking at and then where you are on the field. So we're going to cover 2 different ways to deal with April tags in FRC. Using a coprocessor is the way that we do it. So a coprocessor is another processor besides your RoboRio. Your RoboRio is kind of your main processor. By offloading this, we can do it faster and have it impact our robot less. Photon Vision is a great solution. It's less expensive than Limelight, which is our second option. It can identify April tags, but it can also do retroreflective tape and color shapes. They have a library that you can integrate into your robot that makes it really easy to interface with. You don't have to deal with network tables or whatever. It just makes it very simple to work with. So Photon Vision is really designed to run on a Raspberry Pi or a Limelight. A Limelight internally does use a Raspberry Pi compute module. A Glowworm is kind of this open source camera that was available for a few years. You can run it on other systems too. Some teams run it on like a mini PC. More powerful systems definitely works too. But a Raspberry Pi combined with one of these cameras, you can get a pretty good solution up for around $100, which is a pretty good deal in FRC to get something going for that price. As mentioning cameras, there's lots of different options, but this OV9281 global shutter camera is one of your best choices. And you want to use a global shutter camera if you can. That illustration at the bottom shows kind of what that means. So that ideal with the horse running, that's kind of what your eyes see, right? The horse is running over time. A global shutter is that middle picture. What it can do is open the shutter and capture the entire image in one pass. So it gets a frozen snapshot of the horse running. A regular camera, like even a Pi Cam or the Life Cam, the other options there are rolling shutter. So they'll open up the shutter and then they'll read the sensor from the top to the bottom. If your robot is moving really fast, you'll end up with how the legs get torn there. Your tag will end up getting distorted, so you won't be able to see it as well. So Photon Vision with Raspberry Pi is a great option because you can use a global shutter camera. The Limelight is the other option that we'll cover. You guys are probably familiar with the Limelight. It's been around for several years now in FRC. It's a full out-of-the-box solution, but it costs, depending which one you buy, $350 to $400. Last year, they created a helper. It's called Limelight Lab that you can put into your code to make it easier to interact with. Otherwise, you had to do network tables. And it's open source. I've sent them some pull requests and gotten some stuff added, so that's really great. But Limelight doesn't have a global shutter camera option, at least as of now. Their reveal video did say global shutter expandable, something like that, but they haven't released any sort of solution for how that works yet. So I don't know if for this year there will be an option or not, but that's something to consider, is that if you can use a global shutter camera, you might get a little bit more reliable detection. So just talk real briefly about camera configuration. This applies both if you're going to use Photon Vision or Limelight. What you want to try to do is set your exposure as low as possible, because that means the shutter is open for the shortest amount of time. And so you have less chance for smearing of the image. So having it as low as possible is good, and then use the brightness or the gain to try to boost it back up so that it's visible. And then your resolution, lower is going to be able to process faster, to look at the image and find the tags, but a higher resolution is going to give you better range and accuracy, because if you're looking really far away, if you use a lower resolution, you're going to have less pixels to see. Yeah?
How low is too low for exposure? How do you see the limit of how low you can get?
I'll do a demo with Photon Vision, but you can see a live view of what the camera sees, and then put a tag in front of it and try to adjust it based on what you see.
Can't recognize it at all when you're too low.
Right.
Okay.
Yeah. So we still did do some calibration at the events because the lighting is different than in the shop, but it's a little bit easier to do. So. One extra step that you have to do with Photon Vision that you don't have to do with Limelight is camera calibration. When you first get it set up and installed, you have to use a checkerboard. It has right in it, you print out the checkerboard and then just measure it and make sure the size that it printed right. And then you have to hold it in front of your camera at different orientations for it to calibrate. And what that's doing is looking at the way the lens and the camera capture the image to find out, you know, how the distortion is and everything, so it knows then how to be able to detect the tag and the distance and its orientation. So you don't have to do that with Limelight because the camera is built in and it's an out-of-the-box solution, but with Photon Vision you can use any number of cameras, so you have to go through that extra step. Both Limelight and Photon Vision later in the season last year implemented multi-tag pose estimation. If it can see more than one tag, it can get a better estimation of where you are. So Limelight calls it mega tag, Photon Vision calls it multi-tag estimation. This year they'll be able to run it on the Raspberry Pi. Last year you had to run it on your RoboRio. But the takeaway from this slide is find that setting and turn it on and make sure that it's working, because it really helps reduce ambiguity and noise. If there's little ambiguity really happens when you're looking straight on with the tag. The camera's right here looking straight on it at 180 degrees. It has a difficult time telling the orientation, so you'll have kind of jumping back and forth. But if you had another tag that's right here, that one's not straight on, if it can see the two, it can really reduce the ambiguity. So it's a cool feature if you want to turn on. So now we'll take a peek at Photon Vision. So I have it actually running right on my laptop. You wouldn't do that on your robot, obviously, but you can do a good demo that way. So this is the Photon Vision interface. I have it kind of, my screen resolution low so that everything's a little bit bigger, so you can't see as much as you normally can, but it's here. When you first start it up, you have to go to the settings tab, just like with Limelight. You have to go in here and set your team number. I have localhost because I'm running it on this machine and I'm going to use it with the simulator, but you would put your team number in here, and then you should also set a static network address. You should do that both with Photon Vision and with Limelight, so you always know where to find it on your network. So then this main dashboard tab is the one where you can see the camera and do all your calibration and configuration. So we have our camera selected, we have a pipeline. A pipeline is just a different configuration set, so you can have multiple configurations. If you can use the same camera to do retroreflective tape and to do April tags, or to be your driver camera and to do April tags by having different pipelines. So this one's an April tag pipeline, and then we'll skip over this for right now. And then so here's your input. On this screen resolution, it's very difficult to see here. Do that? No. Let me see if I can make it. So normally it'll be like this, where this shows up over here, so you can see settings at the same time. So if I put a tag in front of it, it should see it, hopefully. Yep, there we go. And so we were talking about exposure before. We would want to try to bring our exposure down as low as we can and have it still detect a tag at the distance that we want. So, but you can also bring your brightness up. But this would be your basic calibration that you'd want to go through. It also has an auto exposure setting that works pretty well. And then here you can choose the resolution for your pipeline. So mine is running at a very high resolution. The frames per second, it comes along with the resolution here. Obviously, if you're capturing more frames per second, you can process more frames per second. If I choose one that only does 10 frames per second, I will never get more than 10 frames per second. Up here it tells me what it's actually processing at. I'm on a laptop, so it's processing as fast as the images are coming in. On a Raspberry Pi, you're lucky to get 30 frames per second is pretty good. So. We talked about calibration real quick. That's another thing that you do have to do before it will do the 3D tags. So here, by default, it'll do these two-dimensional tags. It can identify the tag and give you a little bit of information, but if you want to also get that distance and orientation, you have to do calibration. So I already did that step, but we do that on here. We would say start calibration, and then it'll show up here, and you put this in front of it in a bunch of different orientations and capture the images, and then it will calibrate it for you. Any questions so far? Yeah,
Go back down to the resolution.
sure.
The value that's to the behind the comma, is that what the codec or something like that?
This one, yeah, yeah. The value right behind is the codec coming.
Any codec between the MJPEG and the
Well, the MJPEG would be a compressed format, where the other one would be a RAW format. Depending what camera you have, I'm using the webcam that's built into my laptop, so it's kind of different than what you'll really see. But yeah, I would generally not choose a JPEG format if I can. But see, at this high resolution, there isn't a fast frame rate that's not compressed, because there's too much data going over. So if we go down, I'd have to go down to like the 640 by 480 to get a non-compressed format. But yep, that's something to look for. But this will completely be dependent on what resolutions your camera supports. Yep. All right, any other questions so far? Nope. Great. So I guess one other thing we can peek at here is it, as I show this tag, and so I don't have that resolution calibrated, so it won't let me do 3D. That one, that's the only one that's calibrated. So here it shows me 1280 by 720 is calibrated. The other ones are not, because they don't have values. So I have to go back to 1280 by 720. Hopefully it didn't break. There we go. And then I can do 3D. Down here, it gives me some data about the target. So it tells me the distance it thinks it is from the camera, how far left and right of the center, and then its orientation. So see, when I get close to 180 degrees, and then, so and it has also ambiguity. It can see this very well, so it's, you know, not ambiguous at all. But if it was very far away or kind of dirty, you might get a higher ambiguity, and that might be something you want to try to filter out, the ones that are more ambiguous. All right, so now we saw kind of how you can detect the tags. What are you going to do with them? That's really the thing that we want to know, right? So just quick background, WPI-Lib is the library that we use, you know, for FRC programming. It has some classes built in that help us deal with coordinates and poses. So those classes are translation. A translation is just a point. In two-dimensional space, it would be just an X and a Y. In three-dimensional space, it would be an X, Y, and a Z. A rotation is just that, a heading. You know, 40 degrees, 90 degrees. And then a pose is the combination of the two. So if your robot is sitting on the field, it is sitting at a point and it is facing in a direction. So a pose is our translation and rotation. And then a transform is how it's a vector and a rotation to get from one point to another. So if we're at you know, one spot to get to the other spot, it's what's the difference between the two. So I can apply the transformation to go back and forth between those 2 points. So the transformation is important because when we see an April tag, that's essentially what we're getting. It's telling us how far the tag is from the camera. That's a transform from the tag to the camera, or the camera to the tag, depending which direction. And then our rotation, if we're in three-dimensional space, there's a yaw, pitch, and a roll. We do get all of that data from an April tag, but really our robot, we're just going to assume it's always on the ground sitting forward, you know, not tilted. So we usually do robot poses in two-dimensional space. So we don't care about pitch and roll and its height off the floor. We just assume it's on the floor, not tipping over. Another thing that is important to understand is FRC's coordinate system. It's sometimes not intuitive that X is forward, robot forward is X, not Y. So positive X is forward, positive Y is to the left, and positive rotation is counterclockwise, not clockwise. So this is how it works on a robot. X is forward, Y is to the left. And then on the field, our alliance station is 0, 0. So this is if we're on the blue alliance, this bottom left-hand corner is 0, 0. And if you're standing in the Alliance station, forward is X, positive X, and to your left is positive Y, same as a robot. And then rotation is also positive to the left. But if you're on the red Alliance, 0, 0 is in the top right. And so this is where it gets kind of confusing, and it used to not matter, right? Because we didn't have April tags on the field, and the fields were always rotated images of each other. Well, last year, they're a mirror image of each other. So your coordinates of your nodes changes if you're on red or blue, and when you see a tag, you have to know which side it's on, because they're not mirrored. Tag number 8 is over here on the bottom left, tag number 1 is over here. So the coordinates change depending which alliance you're on. So that's something that is important to grasp. So our ultimate goal by seeing one of those tags is to figure out where the robot is on the field. That's really what we want to do with April tags. Compared to retroreflective tape, we were kind of seeing a target. We didn't care necessarily where we were. We cared where we were relative to the target. We try to turn left or right, drive forward, backward, whatever, to get to the target. April tags tell us where we are on the field, and then we would want to use somewhere on the field as our target. So how does that work? We use the tag to estimate the robot's pose by configuring the pose of the tag on the field. So that's where, back here, FRC is going to tell us where are the different tags on the field. So that's built into both Photon Vision and Limelight. After kickoff, at some point, they'll release an update that just has that built in, ready to go, so you don't have to set it up. But then you have to configure where is the camera on your robot. So you measure from the center of your robot to the position of your camera, forward, backward, left, right, as well as the rotation of your camera. Because when you see a tag, it's going to tell you where is the tag in relation to your camera. What you really care about is where is your robot, right? So you have to do that additional transformation. So we have our April tag on the field. We have our camera on the robot. This right here is a transform between where our camera is and where the center of our robot is. And then Photon Vision or Limelight knows where the tag is in relation to the camera, because it can, when it sees the tag, it knows that information, so it gets a camera to target transformation. And we can flip that around to then say we want to get a target to camera, because we know where the target is, so we can find out where our camera is. And Limelight and Photon Pose Estimator is a built-in class. They calculate that for you. So if you get everything set up, you just ask the Limelight or the Photon Vision, where am I on the field? And then when it can see a tag, it'll give you an estimate of where it thinks you are. So we do that by using the WPI Live built-in pose estimators. If you've done odometry before, it's very similar to that. It actually starts that way. Your odometry is, you use your encoders and your gyro, you feed those into the odometry class, and it keeps track of where you are on the field. So you start with that, and then you can feed in vision poses. When you can see a tag and your camera tells you where you are, you feed that information in too. And then the pose estimator handles the math to fuse those two and give you a pose estimate. And you can configure it to say, I want to trust my gyroscope more than my vision tags, or I want to trust my encoders more than my vision tags, or I want to trust my vision tags more. Generally, your odometry is going to drift over time as you get pushed around, or the carpet even moves a little bit, your wheels spin. Your gyroscope will drift a little, but your April tags are going to be pretty reliable as long as you can see them and they're not ambiguous. So there's different pose estimators for each drivetrain type. You just pick the right one based on your drivetrain. Differential is for tank, Mecanum is for Mecanum drivetrains, which we don't see as much anymore, and swerve drive. So here's some code. It looks a little bit scary, but we'll walk through what we're setting up here because it's really not that complicated. So we have to configure where is our camera on the robot. So we said that would be a transform. So we're going to create a new transform. It's going to be a 3D transform because it's off the floor in our case and rotated. So a transform 3D. And then if we remember, a transform is made up of a translation and a rotation. So we have a translation first that has our X position from the robot to the camera. So this is saying that it's 0.06 meters forward of the center of the robot. It's negative 0.2 meters Y, which is negative is to the right, so it's 0.2 meters to the right, and it is this far off the ground in meters. And then our rotation, we're saying is pointed straight forward. It's pointed upward at 15 degrees, and it was slightly off kilter by 3 degrees also, turned to the side. So now if we get a position relative to the camera, we can apply this transform to find out where the robot is relative to that. So we now have this value. We create our photon pose estimator, which is part of the photon library, and it needs a couple things. It needs first that robot to camera transform, so that's why we set that up. We set it up, and now we don't have to worry about it again. We have to tell it where the tags are on the field. That's something that's built into WPI Live. We can use this right here. And then we have to give it a strategy for how it's going to do the processing. So I talked about earlier multi-tag. This is the multi-tag on the coprocessor. You can also, there's several different strategies. You can tell it like which one is closest to the center of the camera, or various strategies. Multi-tag is probably your best strategy to use. And then you have to give it this photon camera instance with the name of your camera that's configured in Photon Vision. So I have that configured right here. It's OV9281, just so it matches my 2023 code. So this stuff you set up at the top of your code. You don't have to call it again. And then to feed the information in, you do this. You call photon pose estimator update. And that goes out to the camera and asks if it can see any tags right now. And if it can, it returns an optional with an estimated robot pose in it. The estimated robot pose is a 3-dimensional pose. And it'll be the pose of your robot because you gave it the position of the camera on the robot and it knows where the tag was. So it's telling you where it thinks it is, and we can just feed that into WPI Live's pose estimator. That we're also feeding our odometry information. We give it a 2D version of that, and then you need to tell it what time did it see the tag and do the processing, and that's also just built in. You can just get the timestamp and feed that in. So with this code, now when it sees a tag, it can feed that and fuse it in with your odometry and know where you are on the field. For Limelight, it's very similar. We're gonna get the network table entry for bot pose, and then WPI blue if we're on the blue alliance, red if we're on the red alliance. And then this is doing some extra work to calculate the timestamp and then create the pose based on that data, and then we add the vision measurement. So I was putting together this presentation and I found that it was harder to get the timestamp than it should be. So I sent them a pull request. Hopefully they will accept it. That it would be as simple as calling get bot pose estimate WPI Live blue, and then it would return an object that has the pose and the timestamp. So hopefully by the time the season starts, it's something as simple as this with Limelight. But even still, it's bringing this code in and just using that over and over. Any questions on that so far? Yeah.
So how would you integrate that with the gyro, like quickly into your
So the question was, how do you integrate that with the gyroscope and get that estimate? So this pose right on this one, this pose estimator, we're constructing that in the same way that we construct the odometry today. When you construct the odometry, you give it your current encoder positions and your gyroscope, and then you call update in your periodic loop. You do the same thing with the pose estimator. It still has that same constructor, and then it has an update method that takes either your swerve module states if you're doing swerve, or your encoder positions and your gyroscope. Yep. So it'll take those two and fuse them together and make a decision about where you are. Yeah.
Can you go back to the photon vision, the like extinction mode?
This one?
Yeah, no, but the one with the code.
The code? Sure.
Yeah. In the rotation degree, like the second, is that like, is 15 negative like up or down? Like, what, how does the, what, I guess my question is, how does the angle this way work?
If I remember right, negative is the camera is pointed upward.
Okay.
Yep.
But, yeah.
Yep. I'm not 100% positive on that.
Double check it.
Yeah, I'm
That's
like,
a big question.
yeah, sure. Yeah.
So, on this slide actually, the load tag layout field, is that where it's gonna load either red or blue? Will it load it automatically?
I kind of skipped over that. Yep. So you can. The question was the here where we're doing the loading the tag layout. Does that automatically load the red or blue? And it does not. So the object that you get back from this has a method on it that's I think it's set. I can't remember. But you tell it, are you on the red alliance or the blue alliance? And I think it's blue by default. So you can, there's a method on the driver station that you can call to ask it which alliance you're on. You would feed that in. Right, because the coordinates change depending which alliance you're on. Yep.
Well, my other question is, why would you want to have two different sets of coordinates and not just say, we're always going to use blue alliance coordinates moving this around the red?
You could do that. The question is, why wouldn't you just use the same coordinates? You could do that, but all the tools are built around not doing that. That your 0, 0 is always the corner of your alliance station. So, like last year, we used Path Planner. Path Planner had it built in to know that it wasn't a rotated field, it was mirrored, and it would automatically mirror your paths and your autonomous. So like it was all built around that being the way that you drive. Yeah. Because otherwise, like forward from your alliance station when you're on red would be negative, and so everything would kind of be flipped around. All right. So you can see kind of how it all comes together. So we have this pipeline running. I'm going to just make sure that's still working. Yeah. So I have Photon Vision running. This would be running on your robot. It uses network tables to connect to your robot. It's telling me down here it's not connected to my robot. Well, I'm going to run the simulator. I'm going to run my code that I've been working on over the summer. It should, so there's going to be no odometry data because my robot is not moving. But I'm feeding my estimated pose onto this dashboard here. You can see my robot is down here in the corner. What I'm hoping to do is hold this tag in front of the camera. This is tag number 1. So if we go back all the way back here, tag number 1 is down here in front of the red alliance. If I hold that tag here and I hold it here for a little while, I'm expecting it to estimate my robot is right here facing in front of the tag. So hopefully that works. There we go. I have it turned kind of funny. But see, based on where it sees that tag in relation to the camera, it's moving the robot around. So this is where you can configure how much is it going to trust this compared to the fact that the wheels aren't moving and the gyroscope isn't turning. Do I want to trust my April tags that much or not? This is just the default configuration, and it trusts it quite a bit, which is probably the right move, because over time it's going to drift quite a bit with your odometry. Any questions? Yeah.
For how much you trust, or use like standard deviations?
Yep, it uses standard deviations to configure that, yeah. Any other questions? Alright. Well, hopefully that was helpful. Thanks. Got just a couple of resources on the last page. Photon Vision documentation. Definitely go to Chief Delphi. If you've never used Chief Delphi, check it out. Lots of good information, lots of good people on there. I like to, I think I misspelled it here. I like to lurk in the technical section, not as much in the other stuff that goes on there, but the programming, if you have a programming problem, post your code there, put it on GitHub, you'll get answers from people very quickly. There's a Discord also for Photon Vision. Lots of people are on there giving lots of good information. Limelight documentation, and definitely WPI Live documentation is the first place to go for lots of info. Thanks.